Should we start, Deepak?
Yes.
Okay. So, hello and namaste everyone. I hope you're doing great. First of all, I'd like to thank all the viewers who could make it to this live session on BioAmp EXG Pill. We are really excited to share everything about it and interact with you guys. But before beginning with the live session, let's take a closer look at the teaser of BioAmp EXG Pill.
Dikshant, I have already shot it.
Hello?
Yeah, Dikshant, please
Okay.
go. Yeah.
Now I would like to welcome Vishnu Mohanan, founder of Circuit State Electronics. He is highly passionate electronics engineer from India with more than 6 years of experience in designing and prototyping embedded solutions for various industries. We also have Padmalya Rawal, who is a founder of PR Robotics, who is a maker, hobbyist and currently an engineering student. So without any further ado, let's start the session.
Hey everybody, this is Deepak Khatri. I'll start with BioAmp EXG Pill. So it's a very tiny biopotential amplification device which we have created at Upside Down Labs. Dikshant and Bhavna will tell you how we started Upside Down Labs and how we got to BioAmp EXG Pill version 1 from BioAmp EMG version 0.1. Bhavna?
Yeah, so first we started selling first of all at Tindi Marketplace in 2019. But our first sale was made in July 2020 at Upside Down Labs. Then after that we bought Upside Down Labs.tech and Auric.io in August 2020, thinking of starting two companies or startups, but we are continuing with Upside Down Labs for now. Then after that, we registered Upside Down Labs as a proprietorship firm in December 2020. After that, we got our first B2B client in February 2021. And then we incorporated My Upside Down Lab LLP in March 2021. Then in lockdown, we organized a global competition known as UD Labs Challenge. You might everybody know about it. It was run from May to June 2021. It was many entries were uh, many entries came in the competition, and it was a successful event. After that, we sponsored NetHacks Neuroscience Hackathon in University of Alberta, which is in Canada, in July 2021. And then we launched this crowd supply campaign in August 2021, and here we are in this live session. So Deepak, you can continue from here.
So we'll take a look at how it started. Uh, it was a very basic project when we started off after BioAmp version 1.5. We created BioAmp EMG Pill version 1, which is something like shown in the picture, the first picture. It was bigger than BioAmp EXG Pill. The uh, the form factor right now is pretty small and very versatile. It was not like that when it started, and it was only limited for recording EMG signals. Then we gradually improved it, and we created BioAmp EMG Pill version 0.6 that has those uh, affordable way of creating a biopotential electrode with your BioAmp device. Then from BioAmp version 1.7, it was just improving. the functionality of BioAmp EXG Pill. BioAmp EXG Pill is basically the same as BioAmp EXG Pill version 1. It's just that we have incorporated many more functionality in terms of configuration options, and we tweaked some hole placement and other things to make it more usable. And here we are, and I can show you the BioAmp EXG Pill right now. We have these black PCBs from PCB and we have assembled some prototypes. It's working great. All the biopotentials can be recorded with this. I have tested ECG, EMG. I'll post many more videos showing EOG and EEG. We'll also show some demos in this live session. Uh, check for that. So talking about the functionality of BioAmp Pill, it can be used in three ways. You can directly use pin headers, or you can use the castellated holes and use it as a module, or you can use electrode holes. All the information that we are showing as the functionality of BioAmp Pill is also available on the GitHub repository and on the crowd supply page. This is how it looks from the back. You can configure its filter, gain, configure electrode count, like you can use it in two electrode, uh, you use it with two electrodes or three electrodes. I'll just make it large. Yeah, now it's visible to you. So you can also configure band pass. It can be used with Arduino Nano or any other 5-volt compatible microcontroller. If you have 3.3-volt compatible microcontroller, just use a voltage divider, just like Padmalya used for his ESP32 based BLA keyboard. He'll probably show his demo live here if he has set up the okay. So this is how you connect it to Arduino Nano. We'll also show other diagrams, also upload other diagrams on the GitHub repository and crowd supply page. Starting with the EMG, you can hook it up to any old nerve or muscle, just like we have connected it near ulnar nerve. Basically, you record muscle, not the nerve. So we have connected near ulnar nerve, and this is a sample video. The claw is created by Padmalya, and it is controlled by EMG signals coming out from the muscles near ulnar nerve of my arm. Okay, there's a bandwidth issue with my network, so I'll start with asking feedback from Padmala and Vishnu, who have already used it for their projects. Will shed some more light how it can be used and what are the things they want to be improved. We have already discussed some of the things. They'll share some other points. Vishnu, you want to go ahead? Padmala? You guys are on mute.
You're muted, Padmala.
Yeah, I think I'm now audible.
Yeah.
So I think I should start with the project which I have created.
Sure thing.
So let me just put on my. Here is the electrode which I'm going to place. So here I have placed three electrodes. First one is here, second is here, and the reference electrode is here. So here I have already created a small circuit on the breadboard. Here I'm using ESP32, BioAmp EXG Pill, and as said by Deepak, here I'm using a voltage divider. And here is the LED for the indication. Like when I blink my eye, LED will turn on for a second. Now I'm going to attach the crocodile clips. So now our setup is ready. Now I'm going to power the ESP32 board. So now actually what the project is a BLE image capture. The BLE command will be sent by ESP32 to my smartphone. Now here, as you can see in the here, the I have opened the camera application. So here is the ESP32. They are not connected with any wire. They are connected over the BLE. So whenever I blink my eye, it will capture the image. It's clearly visible, I think. So this project works exactly with what I wanted it to be. So right now we are working to make it more easily wearable. Like right now we are having everything on the breadboard. So what we are working on is like we will create some type of 3D printed uh, attachment which you can just wear, and every circuit like ESP32 or IBM BioAmp EXG will be embedded in that circuit only. So this is all about what I have created.
Yeah, awesome. Uh, Due to bandwidth issue, there's significant bandwidth issue in my Wi-Fi right now. Bhavna?
Deepak?
Yeah, there is a bandwidth issue with my network right now, so I'll just go ahead with the presentation, then we can discuss things further.
Uh, First of all, we have a question.
Okay.
So,
Okay, I'll
Yeah,
just
Vishnu.
Okay,
So
I'll
unfortunately, I
just
was
I
not
think
stop
we
able
can move.
to.
I'll just stop presentation.
I was not able to hear both Deepak and what is his Patmalya, but I was able to see Bhavna and Dikshant video in live, but not able to see
Okay.
any other presentation. The video
Maybe.
was breaking, the audio was breaking. I'm not sure if it is a issue on my side. You can hear me, right?
Yeah, we can hear
yes,
you.
yes, we can
Yeah,
hear.
we can hear you right now.
It
Maybe
was
there is
Okay.
some bandwidth issue.
there is a bandwidth
Okay.
issue
So
with my Wi-Fi today, so
Deepak will be joining in a minute. Till then, we can move forward. If you can give some views on the design of a BioAmp EXG pill.
hello.
Yeah, sure. Yeah.
Yeah.
So I think I have never seen any kind of designs like this before. So like for measuring the biopotentials and using it for any digital control application or anything. So uh, most of these designs we have seen. So for example, we have the Hack EEG. That's an open source project from Starcat LLC. So that's actually used for measuring all the EEG and everything. So it's designed for the researchers actually. So it's not actually meant for the average maker to use for their applications or anything. So it was just meant for data collection for research and that kind of purposes. So, but unlike that, BioAmp EXG Pill is different. It's like the form factor. Starting from the form factor, it is compact, small. It's just a pill-sized PCB. So it has a fewer components. That means the BOM cost is low. Anybody can get it easily. The op-amp is a generic one. You can buy it from any manufacturer. You can tinker, modify that design and design something on your own. You can do that. So it's open source. So that means it's a brilliant design. And yeah, you have iterated through many designs, many versions of that. You have improved the designs a lot. So that means the final design you have right now, it's a better than any other designs, any other versions you have. And usually most of these analog designs, any they're starting with electronics, they will be like reluctant to include this kind of analog designs in their design, except they go for so they're actually they actually lack this kind of designs in their applications. So one barrier is, I think, because designing analog circuits is difficult. It is not easy as blinking LEDs or anything. You need to take care of the voltages, currents, and so many things. So you might have to do some kind of simulations, calculations. So all those things can be tedious can be really difficult or difficult for someone starting with electronics. So I think that's where the upside down labs done a good job. They have created this circuit. They have the PCBs, they have the documentation, they have the examples, both in videos and the ready to use sketches. So that means anybody who want to integrate some kind of controls, like using the muscle EEG signals or ECG or anything, they can simply use these examples and they can modify and integrate into their application, just like Padmalya has shown just a while ago. So I think so that's a UDL actually breaks that barrier for a maker to start using biopotential for their the other side. We have the digital domain, and we have the analog domain. So you guys have done something to bridge that gap from the analog domain to digital domain, so that anybody can use biopotentials for controlling any kind of digital devices, output devices, or anything. So that's what you have done actually. So I have never seen anybody doing something like that before. Maybe there is something that I'm not aware of, but still this is the one I am totally aware of, and really excited about, actually excited when I first saw this design by BioAmp EXG. So that's my feedback on that. It's a really good design. I have used the version point 0.7, and it was working really good, and it was getting the signals, and I was able to, within a minute or something, I could see my pulses on the serial monitor or the serial console. So that means that's when I had this plan for creating a new device with that, a new way of doing something like that. They can really get started with the design really fast with the BioAmp EXG Pill. So that's really, you all have done a really good job at that, creating the documentation, illustrations, and everything. So that's a really good, well done job actually.
Thank you so much, Vishnu.
Thank you, Vishnu.
So, yeah, I think that's an important part, that BioAmp EXG Pill caters to a large audience. First of all, it is for beginners also. who are just starting with these kind of projects that measure biopotential signals. And also the researchers can also use it. Maybe it is a single channel, so maybe some researcher want to use a multi-channel, they can use multiple BioAmp EXG pills for that. So it caters to beginners and it caters to researchers also. So now, PR Robotics, Padmalle, are you here?
Yes.
Hello.
Hello. Yes, I'm here.
And for everyone
Am I audible?
who were talking about the design, so I pasted the link for
Uh,
GitHub repository also on the chat on YouTube. So you can go there and see the schematics and see all the designs of BioMP pill starting from version 0.1 to then 0.6, 0.7, and then now 1.0 beta.
Bhavna, can you hear
So
me?
Vishnu, I have another question for
Please
you.
unmute yourself.
So you talked about
I
a
think Dikshant
project
cannot
that
hear us.
you are in process of creating a project, right, with BioMP EXG. So what is that project and how you are making it?
Yeah. So it's a wearable device I'm thinking of. So it will have the BioAmp EXG pill for measuring the ECG or the pulses, and we will have some kind of microcontroller for with ADC for measuring that analog signal. Then we will be transmitting this data to a phone or any other receiver. So I'm planning to use a BLE. So that means you can transmit this data to your smartphone if you have an application or something. So already you have a for BLE protocol, you already have the ECG or pulse rate profiles. That means the Bluetooth profiles, standard profiles. That means if you use those profiles, if you have the data, for example, if you have the pulse data, you can simply use that profile to transmit that data, and you can use any kind of generic application, because this is a standard published by the Bluetooth Association. You can use any application, any smartphone application or PC application that supports this. I think it is called the HR profile, heart rate profile, the Bluetooth profile. So if any application is using that, you can transmit this data to that application, and the application can log it or visualize that. So that is the plan, that is the idea. So I'm planning to use ESP32 for that, some low power BLE5 supported SoC. So I'm planning to use the ESP32C3, which is the latest of from ESP3, and it is a RISC CPU. So that means that it is really cheap actually, 150 rupees or something. So probably the cheapest BLE module I could find. So it has enough features and everything. So I'm planning to use that plus the BioAmp EXG pill, so that you can place that on the chest. That's where I plan to place the device. So it will be designed to have 2 or 3 electrodes, depending on the design. We still have to test that. So it will have 2 or 3 electrodes. We can either use the gel electrodes or the kind of contact pads, maybe made on a PCB or a flexible PCB or something. So it will be battery powered. It will have a battery, and you can operate that for maybe 5 or 7 hours. So it will be transmitting the pulse rate and the ECG for that period. So that's the idea of that wearable device.
Okay. Uh, so that's great. But and you also talked about the electrodes, the gel electrodes, and the other one that we can use with the PCB and pad. Padmalya is currently working on creating a reusable electrode. So Padmalya, can you talk about it right now? Maybe you can show some demo of it. Hello. I think it's still
Padmala is
not
not.
here.
Yeah. Deepak, are you here?
Yeah, I am here. Can you hear me, guys?
Yes.
Okay, so I'll just go ahead and
Hello, Deepak.
Bhavna, I
Maybe
think.
in meanwhile we can show them the main page of crowd supply. So I'll just share that and explain what is there on the crowd supply page. Yeah.
Hello, Bhavna.
Yes, Deepak.
I have disconnected Dikshant. Maybe Dikshant.
Yeah.
Hello.
Yeah, you can hear us now.
Yeah, I can hear you.
Okay, so we were talking, but you were not able to hear us. I disconnected you. So I'll just go ahead and complete the presentation first. It shows all the demos we have prepared.
Just a second.
Yeah, Bhavna, please go ahead. You can show the
Yeah.
demos. Here you can see the BioAmp EXG Pill. This is created by Mayo. He is one of our beta testers. Uh, Next. This is a very early prototype which I created on a single copper clad board. Bhavna, can you if you can show it? That would be
Uh,
yeah. You can see all the wires on the copper clad board, and it's working great. It was the earliest design for recording EMG signals only. Then we improved the design to record all the other biopotential also. This is the electrode placement for EOG when you want to record vertical movement of your eye. Here I am recording the vertical movement and detecting eye blinks on Arduino Nano. We are not using any dedicated PC or fully fledged computer for detecting these blinks. We have our own uh, peak detection algorithm that can run even on very tiny microcontrollers like uh, Arduino's at Mega 328P, or even smaller microcontrollers that can run on 8 megahertz above. This is the electrode placement for horizontal movement recording, and here we are recording the horizontal movement. This was recorded with BioAmp version 1 alpha. The beta version is provides more accurate and more cleaner signal than this. It is clean, but version 1 beta provides much cleaner signal. This is the electrode placement for recording lead 1 ECG, and here we are recording lead 1 ECG, and I'm detecting the ECG peaks on Arduino itself, on Arduino Nano. To record ECG, you don't need to connect the electrodes near your chest. You can create a circuit that goes through your heart, even if it is directly through your arms. So you can connect electrodes on your wrist and one reference electrode behind your hand or somewhere else on your body, and it will record ECG. You can see that in this demo, I have connected a buzzer on pin 13, and when it detects a peak, uh, that was all. The Those were the demos. We have many more demos coming up. There will be a playlist explaining all the examples that are available on GitHub repository. Bhavna has already shared all the files, GitHub repository, uh, documentation and everything. I hope you guys go through it, and if you have any question, you can ask right now. And then I guess asked a question which I haven't answered yet. So he asked how we created this BioAmp EXG pill. Now, if you can show the schematic. Sorry guys, my bandwidth is not allowing me to show or uh, like show anything
Just
right
a
now.
second.
Yeah.
Yeah, just a second.
I'll start with the explanation. So, for recording any biopotential signal, you require only interface that can record the signal without loading the interface. By interface I mean the skin. So it shouldn't load or provide any load resistance that already is offered by your skin. Every skin is different, so there will be uh, resistance in some mega ohms. Our BioAmp EXG pill has input impedance of more than a giga ohm, or tera ohm 10 to the power 12. Individual amplifiers offer 10 to the power 12 input impedance. We are using it in instrumentation amplifier, so that's the like basic of how you record bio potential signals. You don't load the skin. For that, you create instrumentation amplifier. Here we are using two operation amplifier version of instrumentation amplifier on version 1.5 of BioAmp. You can see the three operation amplifier version of instrumentation amplifier. This is just to provide a buffer for the biopotential signal. This also provides a very high CMMRR, also called like that that is an abbreviation for common mode rejection ratio. So it has a higher CMMRR than the individual amplifier. It is about 125. I'm just estimating the CMMRR here. The individual amplifiers offer 105 dB of CMMRR. Then the signal, which is amplified by 10 times, goes through that 1000x gain bandpass filter, and that's how we record these biopotential signal. And then I guess also asked how I came up with this design. I was explaining that also, but I guess the bandwidth didn't. So yeah, I'll go ahead and explain it again. It was started in 2016. I was reading about biopotential signals and how to record, and in 2017, I created my first design using that three operational amplifier version, and since then it is improving each year. And in 2019 I released BioAmp version 1, then in 2020 BioAmp version 1.5, and in 2021 BioAmp EXG Pill is here with Upside Down Labs. So it, it took me a lot of research work and patience to know how things work, how instrumentation amplifier work, and it is not necessarily the work of how things work on like how things are explained in a notebook or just a textbook. Things require some practical uh, like prototypes, because the biopic chipel is not very easy to understand. If you see, the 10,000 gain is very high for an ECG signal, but it records it very well without overshooting or clipping the signal. That is because it is using a very clever design where we are not recording signals above 3 hertz at maximum gain. So it is recording signals above 3 hertz at a lower gain than it is recording in the range of 1.5 and 3 hertz. Probably it is very confusing right now as I am telling you, but there is a issue created by somebody on the GitHub repository. You can check that out. I have explained it how I am recording the biopotential signal without clipping, without the signal clipping. I hope I have answered it. If you have any other question, please let me know.
Uh, he's also saying one more thing. He's saying, speaking of research, a lot of EMG amplifiers I've seen use some fancy components to increase input impedance and decrease noise. But your choice of TL084 seems rather unconventional.
Yeah,
Is there a reason for this?
yeah. I started off with LM324, TL074, LM358. I uh, experimented with a lot of amplifiers, but any amplifier with a JFET input provides a higher throughput. So you record the signal at a higher, uh, the clarity is better with this TL074 because the BioAmp uses the JFET input amplifier. You can replace the same this TL804 with a LM324. It is pin compatible, but the output will not be as good as it is right now. So it is not about what operation amplifier you use. It is also about what is the type of amplifier. Like JFET input provided me better results, but JFET input amplifiers are usually rated with higher minimum voltage requirement. Like TL074 in its older form factor requires 7 volt and above. Right now they improved the design and it works with 4.5 volt also. But yeah, you can use any other operation amplifier. Just follow the circuit and you'll get the output, but it will be not as good as it will be with TL074 or TL084. TL084, the older version, is not compatible with TL074. I mean, the signal is good with TL074 and the signal will be noisy with TL084. That's how they designed it. Both the chips come from same silicon wafer, but they choose the better working dies for TL074 and the dies that are not working good for TL084 only for the older version. But the newer design TL084H and TL074 both are exactly the same. We have confirmed that uh, from Texas Instruments, and that's why we are using TL084 in the uh, version 1.0 beta. We were using TL074H before, but yeah, you can use any of them as long as it is available. TL074H was not available when we were in a hurry to buy, so we bought a TL084. Any other question?
No, not for now.
So if you allow me, I will show the 3D printed reusable electrodes which I
Yeah,
was unable to
definitely. Yeah,
demonstrate.
please go ahead.
Uh, so here is the first version which I have created. So we can attach we can attach a band on these hinges. So this is quite thick and you can't bend it, and it is printed with PLA material. Then I printed the another version. This is also PLA, but you can bend it slightly, and it you can use only one electrode. So within few weeks, I have a lot of reusable electrodes. Like I can't use them again according to the data sheet or something. So then I have created this one. It in this one we have the two electrodes. You can easily wear it like a band. Let me just wear it and show you. So you can wear it quite easily. So yeah, but here in this version I don't have any type of wrapping so that I can like have some uh, make it a closed loop which is quite thick, so I can't bend it as well, so it can't be bent. So then it's my latest version. So here, if you can see here, I have extruded some of the cylinders, little cylinders, and on the other side we have the holes, and it is also printed with PLA. And if you can see here, it is quite flexible. What I did here is I just printed it with two layers only, and I can easily anyone can easily print it within 30 minutes only. And here we have the two electrodes, uh, two pins which I have extracted from the electrode itself, and you can easily wear it, and it can be easily snapped in place. And it is here the joint is quite strong. Here I have just attached only two or three. If I attach it or more, like this one. In this here I am attaching almost four, so it is quite strong now. You can you can you can't easily open it. So it may break if you like use more force, but when you wear it, it is quite flexible. So if anyone requires files of this one, we will also attach in the description. So yeah, that's it.
Thank you, Padmale. So NNI also asked that they use different or fancy components to increase input impedance. Yeah, that is one another reason why we used the JFET operational amplifier, because input operational amplifiers provides the highest input impedance available for all the operational amplifiers. You can confirm that with all the data sheets, LM324 and TL074. Yeah,
He's asked one more
triple NI.
question. Triple NI,
Yeah,
yeah.
triple NI.
He's asking that do you have noise figures available and a frequency response board plot?
Yeah, we don't have it right now. I'm in the process of creating the simulation with Texas Instruments Tina and PSPI specifically made for Tina components. Yeah, I'm simulating the circuit, the recent circuit. It will take a week or so, hardly. So the next plan is to record other example projects, and all the example which we have provided on the GitHub repository. We will be sharing them through our crowd supply campaign and also through our social media platform. So you can also just uh, follow the project on GitHub. That way you'll also get the chance to like keep yourself updated when we post new code or new link or whatever we update. You'll get notified. Yeah. Okay, so you got it. uh, I guess that was all from my side. If you have anything else, Padmalya and Vishnu, you can share. uh, I'm really sorry for my bandwidth. It created a lot of problem today. Hopefully the next time uh, or the next live session will be better than this. Yeah. Vishnu.
Yeah, I would like to know about the like the future revisions of the BioAmp EXG Pill. So, are you planning to make any other boards or um, any like a ready-to-use controllers or something like say game controller or something? You plan to make anything like so? So, what is the future plans for the BioAmp EXG Pill? I want.
Yeah. So BioAmp EXG Pill right now only works with 5 volt. Anything above 4.5 volts and within 40 volts will be good for BioAmp EXG Pill, as the TL04 H or TL074H or TL084H allows you to run with that voltage, but it is not something that every microcontroller out there, the current microcontroller allows you to use. So what I have planned is to use a voltage inverter and provide the operational amplifier with positive and negative voltages. So even when you use it with 3.3 volts, it will provide it with 6.6 volt. The minus 3.3 volt will be provided by inverted the inverter. So it will work with above 4.5 volts, so it will be fine. uh, yeah, that is something which I have planned, but there is an issue with that the middle point will always be 0, so you will be able to record EMG signal or differential signal that doesn't require you to uh, get the smooth signal. So EMG will be recorded very well with that amplifier or that BioAmp EXG Pill design. So to resolve that issue, it is much better if we incorporate a simultaneously sampling ADC, something like ADS 1115 or ADS 131M08 or M0X, that is 24-bit operation amplifier. Sorry, 10-bit. Sorry, a 24-bit ADC. ADS 1115 is 16-bit ADC. That is not simultaneously sampling ADC, but ADS 131M0X is simultaneously sampling ADC with 24-bit resolution. So I plan to create a board that will have the BioAmp design, but we'll use a dedicated ADC on the board, so you can hook it up to your microcontroller through I2C and directly record the signal. And it will also have 4 plus inputs with like 4 inputs with ADS 1115 16-bit 4 channel device, and with ADS 131M08 it will be 24-bit resolution device with 8 channel input. So that is something which we have planned. Other than that, the BioAmp EXG Pill design will be used with LM3 to 4 to create BioAmp version 2. Hopefully, it will be released uh, by the end of 2021. It will use exactly the same circuit as BioAmp EXG Pills with some minor modification, and it will come hopefully in a form factor of an Arduino shield, so that anybody who wants to use it for learning neuroscience can use this affordable neuroscience kit, which will be compatible with backyard brains, EMG spiker shield, and other spiker shield offerings from them. Vishnu?
Yeah, that's great. That's great. So, I also had the confusion about like how to power this device properly. Like, usually you want, if you want to plug the Arduino boards and everything will be plugged directly into the laptop, and the laptop will be usually connected to the mains line also. So, uh, powering this device, like if you have 10 devices, and 10 individuals will be connecting this to different power supplies, so you cannot know what kind of noises are going to affect their measurements. So if you have a reference design for the power supply, like uh, say you can power from 3.6 volt lithium ion battery or a power bank. So if you have a reference design for the power supply, then you can, they can minimize the noise, the effect of noise, power supply noise, and they can get a clean signal from their whatever kind of measurement they're trying to make. So that is something I think UDL has to think about, and come up with some design or something, maybe an add-on board or something, so that you can plug this BioAmp EXG Pill on that. So that was, I had that confusion, because when I connected my EXG Pill to my laptop, it was already connected to the mains, and it was picking up the noise from the mains noise. So the ideal voltage was not stable. Only when I connected the reference line to the body, I was able to get the clean signal. Then one other issue was when my leg was touching the ground, the signal would vary. Some substantial variation was seen when I was touching my leg on the ground. So when I was raising my leg, the signal was back to the proper shape. So I think it was due to the power supply. I think because the laptop was connected to the mains, and it was acting as a common ground. The earth was acting as a common ground, so it was affecting the signal. So I think if you have a reference design for the power supply, so that you can have multiple inputs like a battery input, multiple kinds of battery inputs, and you can have a power bank. So that will be the better sources, power sources for the BioAmp EXG Pill. So that will, so that you can, they can, everyone can get a clean signal from their EXG pills. So I think you should consider designing something like that.
Yeah, that is something which I experienced with version 0.7 of the device. It uses some current limiting input resistors for the electrodes. So that is causing that issue which you are talking about. When I uh, put my leg on the ground, it picks up a lot of noise. That was only for like only that was only a problem with version 0.7 due to those current limiting resistors. On version 1 it is not a problem, and even if your device is connected to any power source, AC, like charger, your laptop is connected to your charger, or you are using any crappy power bank. Some power banks also create very high pitch humming noise, and I have that kind of power bank. It is not picking up that high frequency noise right now, but it was when I was using uh, version 0 point of the device. So I have resolved that power supply issue. Any power supply that is uh, like somewhat cleaner, any power supply would work, because I have also included higher capacity, like higher capacitance capacitors on the input. So we have 4.7 microfarad capacitor right now that eliminates all the noise, along with a 100 nanofarad capacitor. Bhavna, if you can show the uh, schematic diagram, it clearly shows those two capacitors. So the input is filtered by BioAmp EXG Pill version 1 very well, which was not the case for BioAmp version 0.7. So all the noise which we were having with BioAmp version 0.7 will not be uh, visible with BioAmp version 1. In the power supply filtering section, you can see two capacitors, 100 nanofarad and 4.7 microfarad capacitors, which were not available or not connected with a input power supply in version 0.7. There were only 100 nanofarad capacitor, and I listed a 1 to 2.2 microfarad capacitor in that design. And probably your board is just using 100 nanofarad capacitor. That's why it is causing that much problem. Uh, all the signals will be recorded very clearly with version 1 of the device, hopefully. Uh, I'll I'll still
That's great.
yeah, I'll still provide some reference for the power supply. Some guide should be there, so yeah, definitely I'll do
Yeah, that's great. That's great. I must really try the version one, I think.
that. Definitely.
Yeah.
Uh, other
Another product which I would
Yeah, please go ahead.
uh, Another product which I would like to say is like, can we create some type of shield, multi-channel shield? Not exactly the shield, like a hat for Raspberry Pi, so that we can combine our project with the ML or AI something.
Definitely.
Like there is something
Yeah,
multi-channel.
yeah, yeah. That's the problem with the current design. It only works with 3.3 volt, and we'll have to use voltage divider for the like input. So I think it would be a nice thing to complete the design of the dedicated ADC incorporated by M design before we go with that Raspberry Pi or even a BeagleBoard cape. We can create both. Uh, that would be awesome to record biopotential signal on those devices and use, as you said, use ML and AI directly on the hardware and deploy it on the edge. Yeah,
Deepak, Triple NI has been saying something. First of all, he has asked, have you looked at low voltage CMOS op amps like the MCP602? The input bias impedance is comparable to JFET input OP amps, and they can run off 3.3 volt as well.
yeah, I looked at the design, the datasheet of MCP602. Uh, One thing that uh, is very clear that those MCP amplifiers are not readily available here in India. The TL04H as is also not available, but it can be easily procured from Texas Instruments, as they have enabled that a company buying option, so they handle all the GST and stuff. That is kind of an excuse, but definitely it can be used. It has very good input impedance and characteristics. I'll definitely try it out for the next design, and we'll see how it goes.
Also, he has said that you can also add
Ferrite,
ferret beads.
yeah,
Yeah,
that
sorry.
was that was a thing that I considered in the very first design. I guess it uses a Farad bead, the version 0.1. Then due to an availability and how I modified the circuit, later it became something that the BioAmp EXG Pill doesn't really require. The input is okay. So he was able to procure the MCP 6002 uh, locally. So yeah, I was telling about the Farad bead. So I
Yeah.
used it for the previous version, but the recent version doesn't really require it. So that's why I removed it from the recent version. It was there in the version 0.1, I believe.
Okay. He's also saying that I was actually able
Yeah,
to get
yeah, I
MCP
saw.
602 in a local store. Yeah. So that's great.
I'll see if I can procure here in Delhi and try it out with the newer BioAmp version 2 device. So it requires it is required to run it off 3.3 volts, as uh, yeah, the new version should be able to use 3.3 volt input instead of this limiting 5 volt input right now. Yeah, I got the point. Yeah, I got the point that you can use a Farad bead on the op-amp supply pins. Yeah, I used the Farad bead in that way only. You can check out the version 0.1 design. I'm answering the triple NI question.
I don't think we have more questions for now.
Vishnu, do we have any question regarding something you are creating or you want to create with BioAmp or something else?
Not at the moment. I want to test it more. Probably I have to get the version one. Then I have to do some more testing. I want to know better. I want to find the better placement for the electrodes. Like there should be a minimum spacing between the positive and negative electrodes. So I want to find that. I want to figure out um, the maximum and minimum distances for the electrodes, and how I can get at least the um, pulses. At least I can measure the pulses. Um, so I want to figure that out. That's one thing. Then there's about this noise and the reference electrode. So these things I have to find out. Like if you're standing in some noisy environment, like there is so much electromagnetic noises and so many switching devices, like tube lights, and other switching devices. So if you're standing near any of them, um, I want to see if this circuit, the bio EXG pill, is picking up those noises. So I want to figure that out. I want to test it and use the data to determine the better placements for the electrodes. So that's one thing I have to do initially for creating the wearable design.
So specifically for the ECG patch, I tried it out. If you use the electrode, like the electrodes were sticking or overlapping, and they were very close, and I was able to record the ECG signal very clearly. It was not a problem. So the designs that other people are creating for the ECG patch is possible with BioAmp Vegetable, that I can assure you. And yeah, definitely you can try it out for on your own to determine if it can be used with your specific requirements for your specific programs.
Yeah, that's great. That's great. Yeah, I will try it then. Yeah.
So,
Well, we have a suggestion from Triple NI. He has an idea about a future product. He says, how about a low noise amplifier, say in the zero point 0.5 hertz to 10 hertz range? I have been looking for cheap variants of such a thing.
yeah, definitely that would be awesome. Uh, yeah, yeah, I'll try to create that, and I'll definitely would like to have a discussion on this on our Discord forum, Discord channel, so we can take this further from there. I guess that was all. If nobody has any other question, we are already above the 1 hour limit, the 1 hour mark. There is no limit actually. We can go beyond that, but I think we should continue it some other time. And I hope you all enjoyed it. If you have any feedback or any suggestion, please let us know in the comment section on YouTube or on a Discord. We'll be happy to review, and we're happy to improve our future online meetings and future sessions like this. There was a bandwidth problem. I am really sorry about that. I hope I have answered all the questions well. If I haven't, you can reach out to me on Discord, or you can send us an email at contact@upsidedownlabs.tech. We'll be happy to answer.
Also, I have pinned the links for BioAmp EXG Pill, GitHub link, crowd supply link, and Hackaday link. And also, I've shared the PR Robotics and Circuit State Instagram handle. So, if anyone wants to check their pages out, you can visit those links.
Yeah, triple and I. Thank you for your questions. You don't have to apologize for asking questions, as your questions made our live event much more successful. Otherwise, it was like not very good, as my bandwidth problem was very bad. So thank you very much for asking those insightful questions, and thank you very much Padmalya and Vishnu for uh, uh, coming to the session. And as Vishnu was already saying that he wanted to go to sleep early, go to bed early, but he is awake just for this live session. So thank you very much, Vishnu, for your efforts and for your support. Thank you very much, guys.
Yeah, it was a nice session. Thanks for having me. Yeah, thank you all.
Thank you.
Thank you so much.
Thank you, everyone.